Okay, today we're going to do 2.3 conditional statements. After this lesson, you should be able to successfully identify and use basic postulates about points, lines, and planes. Okay, a conditional statement is a logical statement that has two parts. It has a hypothesis and a conclusion. When a conditional statement is written in if-then form, the if part contains the hypothesis, and the then part contains the conclusion. And that is when it is in if-then form. So it's got to be in if-then form for you to identify it the way I'm stating this. So here's a statement that's in if-then form. It says, if it is raining, then there are clouds in the sky. The part it is raining is the hypothesis. The part there are clouds in the sky is the conclusion. A conditional statement can be represented in symbols, written P, then an arrow Q, and that is read P implies Q, or if P, then Q. That arrow means implies. Okay. We're going to identify the hypothesis and the conclusion of each conditional statement. Okay? You're welcome. Won't go quite as fast when we're coloring, but we're not coloring yet. We're doing highlighters yet. Okay, so the hypothesis is after the if. So in this statement, angle X is congruent to angle R, and angle R is congruent to angle S is your hypothesis. The then part is the angle X is congruent to angle S. If you see that, if these are congruent, you can drop the R's and say those two are congruent. Example 2, identify the hypothesis and the conclusion and write the statement in if-then form. This one is not in if-then form yet. It says you receive a free pizza with 12 coupons. What do you have to get the free pizza? You've got to have 12 coupons. So if you have 12 coupons, then you receive a free pizza would be if-then form. Okay, and the hypothesis, again, is not including the if. The hypothesis is actually the part that's after the if. Doesn't include the if. Okay, so I'm going to identify the hypothesis and the conclusion of each conditional statement. If you're not using colors, you're just going to do single line under hypothesis and double line under conclusion. I'll do it, but I'm going to also use color. So it is Saturday, then there is no school. It is Saturday is the hypothesis. There is no school. I'm going to change color for the conclusion, but I am going to underline it twice. In the next statement, if x minus 8 equals 32, then x is 40. The x minus 8 equals 32 is after the if. That is your hypothesis, and the conclusion is x is equal to 40. Again, it doesn't matter if you don't have color, you're going to have other ways to do this, and so the same thing I'm doing with color. Okay, and finally, if a polygon has 4 right angles, then the polygon is a rectangle. The hypothesis is a polygon has 4 right angles. The conclusion, it is a rectangle. Well, the polygon doesn't have to be a rectangle. It could have been something else. It could have been a square. But we aren't talking about truth value yet. Okay, good. Go on. So we're going to write each statement in if-then form. This says all apes love bananas. So if you're an ape, okay. If an ape, I'm going to try to be brief as I can on these. If an ape, then you love bananas. Bless you. You're welcome. Or if it is an ape, then it loves bananas. Whatever. Multiple ways to say it correctly. Okay, the sum of the measures of complementary angles is 90. So if it started off with the sum of the measures of two angles is 90. Okay, so the sum of the measures of complementary angles is 90. Right? How would we say this one? Anybody want to give me an if then? Go ahead. Okay, if the sum of two angles is 90, then they are complementary. Okay. I'm going to use a 2, the number, and then the angle symbol apostrophe S. If the sum of two angles is 90, then, comma, they are complementary. And we'll use COMP for complementary. Okay, collinear points lie on the same line. Anybody give me, go ahead, Nathan. Okay, if points are on the same, I'm going to write PTS for points. If points on same line, then they are collinear. Now, I think it could have been written also if points are collinear, then they lie on the same line because collinear had come first here. Okay. So I'm not going to get real nitpicky about that right now. All right. When the blank of a conditional statement is not met, when the hypothesis of a conditional statement is not met, the truth of a conditional can't be determined. When it cannot be determined, it's considered true by default. If a statement is not false, logic dictates that it must be true, is what that says on the box. Oh, true. Sure. Okay, I realized you had to flip your page now in your packet. What was it we talked about yesterday that proves a statement is false? Yay, yes, a counter example. So a counter example proves a statement is false. It must satisfy the if part of the statement, but not the then. So for example, if a statement said, if it's Friday, then there's a football game. Good luck, guys, tonight. What about a Friday night in May? Are you playing football? No. So that would be a counterexample, picking a Friday when there isn't a game. All right. So a Thursday night when there is a game is not a counterexample. Okay, you see how that's backwards to this? So this says if it's Friday, we have to have a Friday then in our counterexample. Does that make sense? All right. If it was having a Thursday and there is a game is not a counterexample because that's satisfying there is a game, but not satisfying the hypothesis. Okay. So determine the truth value of each conditional statement. If it's true, explain your reasoning. If false, give a counterexample. All right. If today is Wednesday, then yesterday was Friday. Okay. We're saying that today is Wednesday. This is false. Yesterday was Tuesday then. Okay, the second one. If A is positive, then 10 times A is greater than A. Well, if you know you have a positive number and you multiply it by 10, doesn't it have to get bigger? It's going to get bigger no matter what. So this statement is simply true. Good. Okay, now's when we're going to use some highlighting. Okay, so we're going to talk about the converse, inverse, and contrapositive of the conditional statement. If you change the hypothesis and conclusion of a conditional statement, you form related conditionals. This chart shows the three related conditionals, converse, inverse, and contrapositive, and how they relate to the conditional statement. The first one is if P then Q. That is our conditional statement. The conditional statement says if P then Q, and that is your hypothesis is P, the Q is your conclusion. In this example, this is where I'm going to use some highlighters. If two angles are vertical angles, the hypothesis is two angles are vertical angles. And then they are congruent. The conclusion is they are congruent. Now, what do you think about that statement? If two angles are vertical, then they are congruent. Is that true or false? And that's true. Okay. I'm just going to put next to here that that's true. The next statement I'm going to do is called the converse. And that switches the hypothesis and the conclusion. So if instead of P then Q, it says Q then P. Okay, this is how we read the first one, if P then Q. The converse is if Q then P. So it switches the order. All right, so the new statement is if two angles are congruent, that's putting the hypothesis the second and the conclusion first. So two angles being congruent is switched with they are vertical angles. Okay, now I want to talk about the truth value of that. If two angles are congruent, do they have to be vertical? They can be congruent and be some other kind. Okay, so this would be false. All right, next we're going to talk about the inverse of the conditional statement. Now, the inverse takes and negates the hypothesis and the conclusion. So it goes back to the original statement, but it says not P and not Q. So if not P, then not Q. And this little squiggly means not. That little squiggly symbol in front of the P and the Q. And so what we do is we insert not or we negate it. So if you already said not, you'd take the not out to make it the opposite. All right, so highlighting what's happening on here is simply if two angles are vertical, that's how the original statement went. It says that if two angles are not vertical, okay, and then we have the conclusion, then they are not congruent. Now, the last one is this big old word, and that big word is the contrapositive. Okay, what that does is it negates the hypothesis and the conclusion and switches them. So it's if not Q, then not P. So if we were thinking about the order that this one goes, you go to the original statement, you add in the word not, and you switch into the hypothesis and the conclusion, and then you switch them. So we've got the conclusion at the beginning, and we've included the word not. Should have put that on there. And then we had switched that with the hypothesis, but we also added not in that hypothesis. Anybody still need this? My highlighters. Can I go? Okay. Just as a conditional statement can be true or false. Oh, I wanted to go back to that for 1 second. I forgot to add something. If two angles are not vertical, then they're not congruent. That's just because they're not vertical, does that mean they can't be equal? Okay, not congruent, not vertical, not congruent. This is false. Oops, I need a pen. Okay, and then the last statement, if two angles are not congruent, then they are not vertical angles. That's very true because vertical angles have to be congruent. So what I wanted to note here was that these are the same truth value. And then from way up at top, a conditional and its contrapositive have the same truth value. Okay, so those had the same truth value. I guess I could have done it here maybe. These have the same truth. If you couldn't fit it in, whether it's true or false. And the first and the last have the same truth. And we're going to put this in our ISN anyway. So let's just continue on. So just as a conditional statement can be true or false, the related conditionals can also be true or false. A conditional statement always has the same truth value as its contrapositive. And the inverse and the converse always have the same truth value. Converse and the inverse. I wrote converse twice. Oops. So the converse and the inverse always have the same truth value. Now, I just was going to make one up quick. If you're driving, if the light is red, then you stop. Would be true, right? You're supposed to. Okay, if you stop, then it's red. Is that true? Because you stopped, does it mean the light was red? If there's somebody in the road, you better stop, right? So that'd be false. So if not red, then don't stop. Well, does that make any sense? If there's a car going through there in front of you, if it's not red, you don't stop is false. But if it's not red, oops, I forgot to write red. If not red, then you're not going to. I didn't write that right. Oh my lordy, I'm writing the same thing over again. I was just trying to hurry too fast. If you don't stop, I should be going back and negating this, and switching the hypothesis and the conclusion. So if you don't stop, then the light was not red. Okay, then that's a true statement. You're not going to, it says if you don't stop, the light should not have been red. Okay, so that would be true. So again, I'm just showing you that these two have the same truth value and these two have the same truth value. All right, so we're going to take this apart right now. This is going to be my conditional statement. It says that if two angles make a linear pair, then they are supplementary. We're going to write the converse of it, and we're going to try to decide whether they are true or false. Okay, so the first statement says, if two angles make a linear pair, then they are supplementary. that statement is true. Okay, now we're going to write the converse, which switches the hypothesis and the conclusion. And I'm going to try to abbreviate this a bit so it's not quite so long. All right, so if angles, well, it should be 2 at least. If 2 angles supplementary, then make a linear pair. Make an LP. And I'm going to use LP for linear pair. Now, if 2 angles are supplementary, do they have to make a linear pair? They could be separate. We mentioned that a few times. So this would be a false statement. Now, the inverse negates the hypothesis and conclusion of the original statement. So if 2 angles don't make a linear pair, and I'll use the abbreviations, if 2 angles symbol apostrophe S do not make LP, then not supplementary. If 2 angles don't make a linear pair, then they're not supplementary is false. Okay? Still can be supplementary, but not make a linear pair. The contrapositive negates the hypothesis and conclusion and switches them. So, if 2 angles are not supplementary, not SUPP, then not a linear pair, not an LP. Now, if 2 angles are not supplementary, then they can't be a linear pair is very true. Because if they make a linear pair, they have to be supplementary. Oh, yes. The next part is your assignment. We're going to go ahead and fill in our ISN now, and then you'll have a little bit of time to work. You're good now? Okay. Okay, we're going into our ISN. We already did the 2.1 ISN, so we would be on the second page in there. I know we've already said this stuff, so we're going to just quickly fill this in our ISN. Conditional statement is a logical statement that has 2 parts. The if part contains the hypothesis, and the then part contains the conclusion. If you would like to use highlighters, I'm going to underline my hypothesis again in one color, pink for me. And I'll double underline it. If you don't have color, you double underline the conclusion. And this one says, if I don't know where that N came from, get rid of that. If 2 angles are complementary, then the sum of their measures is 90. The sum of their measures is 90 is the conclusion. Okay? All right, now, how to write them? It goes if hypothesis, then conclusion. That's if P, then Q. You have to decide if it's true or false. Momento, please. You're going to have to decide also if the inverse or converse or switching it is true or false. Then once you know whether the first is true or false, it's going to match. The statement will match the truth value of the contrapositive. Okay, and that's all this stuff is saying in here, and that these 2 will match. So let me show you what I meant. I don't want to use my blue and green. These 2 are going to have the same truth value, okay? And the other 2, the top, the conditional statement itself, and its contrapositive will match. in value. So this is going to be the same truth value as the contrapositive if you want to shade it in. And I was just doing it for people who don't have color. I was just connecting them on the side. And these will have the same truth value. You don't know that yet. You have to depend on the statement that you're given. So it's why it says you have to decide if it's true or false in the very beginning. Okay? These are not statements that you can decide if they're true or false. The hypothesis, of course, is the first part. The conclusion is the second part. When you do the inverse, I don't like how they switched the order that I was doing them earlier here, but I'll show you what we're going to do in the next section. This is also the hypothesis in this spot. I'm not going to color this. You know what? Let's just wait till the next part. So if you would, let's move on to the next box. Okay. We're going to do this with symbols. So what I would like you to do is use a triangle for your hypothesis and a circle for your conclusion. If you're using color, I'm making my triangle pink and my circle blue. All right, so the original statement is if pink triangle, then blue circle. Okay, again, you've got to decide on your own whether this is true or false. And it will match the last one if it is true or false. Okay, so these are going to have the same truth value. These will be the same. Likewise, I don't like that this all of a sudden is in a totally different order than I was doing it earlier. Do you follow what I'm saying? What we had on the next one was a converse. So I would like you to switch this and this. So if you would please write converse where it says inverse and inverse where it says converse so I can stay consistent. Let's do that. Okay, so the converse is if circle, then triangle. So you're switching the hypothesis and the conclusion. The inverse negates the hypothesis and the conclusion. So it just says if not pink triangle, then not a circle. So I'm just doing it in symbol notation. Ooh. But these two that we just talked about, the converse and the inverse, they're going to have the same truth value. So these two will be the same. And then came the old contrapositive, that ginormous word, contrapositive, which says if not circle, then not triangle. Okay, I'm going to make up a concrete example for you on the next section. Again, our statement is our conditional. Oh, I guess I could have filled that in up here. This was statement is your conditional. And the one, what I'd like us to write in is if two angles are vertical, and I'll just write two angles vert, V-E-R-T, vertical, then congruent. Let's just do it that smart, nice and tight. I know that's not worded beautifully, but it serves our purpose. So in this statement, the hypothesis is two angles are vertical. And the conclusion is that they are congruent. If two angles are vertical, are they congruent? Yeah, they have to be. This would be a true statement. And I'm going to highlight that box yellow because, oh, that's not a yellow highlighter. It was a yellow marker. That's better. Okay, so now I'm going to I'm going to again switch those boxes to say converse first, then inverse, please. So please switch this box over here and say it's the converse and then the inverse. Okay, so the converse is if congruent, all right, if two angles congruent, then vertical. Okay, so now if their two angles are congruent, then they're vertical. They don't have to be vertical to be congruent. So this would be false. And what we did was we switched the hypothesis and the conclusion. So now the conclusion is in the beginning and the hypothesis is at the end of the original conditional. Okay, the inverse is if two angles are not vertical, then not congruent. Well, that's silly. They don't have to be vertical angles to be congruent. So if they're not vertical, then they're not congruent is false as well. Okay, notice that this matches the previous statement's truth value. These are the same truth value. And then finally, the contrapositive would be if two angles are not congruent, their two angles are not congruent, then not vertical. Okay, now that's supposed to be true, so let's think about it. If two angles are not congruent, then they're not vertical. That is true because all vertical angles are congruent. So it does follow or match the original conditional statement in its truth value. So in your box, you could connect, if you want, the top one and the bottom one, and this is connected. I really need to get that whole box on one page. It's kind of silly. All right, that's it for the ISN. So you can do some problems here before we leave in about 8-9 minutes. You got some time, so do not be packing up right now, please. Get something done. And have a wonderful weekend. It is Friday when I'm recording this.